I want to look at breaking numbers down into their prime factors. Before I do that, let's just start with a big important theorem. This is the Fundamental Theorem of Arithmetic. And the Fundamental Theorem of Arithmetic, finish spelling that word, says every natural number greater than 1 is either a prime or can be written as the product of prime numbers. Okay, it also says this product is unique. Okay, let's break that down quick. So every natural number greater than 1. So remember, the natural numbers are 1, 2, 3, 4, 5, 6, and so on. So all of those numbers bigger than 1 is either a prime. So remember, primes are numbers whose only factors are 1 in themselves and that are larger than 1, or can be written as the product of prime numbers in a unique way. Okay, so if I can find a product of primes that multiply together to be a number, that's the only product of primes that can do that, with a possible exclusion of order. Now, if I want to find such a factorization, so here I'm going to find the prime factorization of 12, one of the techniques I can use is something called a factor tree. Now, in a factor tree, I'm going to start with my trunk or root, and then I'm going to draw two branches off of this, and each of those branches is going to be, or those branches together are going to be two numbers that multiply together to be 12. Now, since my goal is to get down to prime numbers, I'm never going to put 1 as one of these branches. Okay, so for example, I could say that 12 is 3 times 4. So 3 times 4 gives me 12, and I've got the start of my factor tree. Now, 3 is prime, so I'm going to circle it because it's done, but 4 is not prime. I can break 4 down into 2 times 2. Okay, 2 times 2 is 4, and 2 and 2 are prime. So here's my factor tree for 12. Now, you may be saying, well, but when I think about 12, I don't think of 2 times 3. Sorry, I don't think of 2 times 3 because 2 times 3 is 6. I don't think of 3 times 4. I think of 2 times 6. Okay, well, let's make the factor tree starting with those branches. So here, 2 is prime, and then notice 6 is not. I can break 6 down into the factors of 2 times 3. So 2 is prime, 3 is prime. And if you look at the circled numbers here in both of these trees, I have the same numbers. I have 2 times 2 times 3, except maybe for the order. It can be really helpful once you have these written down to write them in increasing order of prime. So I've got 2, and then to the powers instead of writing out each factor independently. So I have 2 twice in these factors, and then times I have 3 ones. So 12 is 2 squared times 3.